in the region, we have all the steel making, and also Haynes International company, the alloy manufacturer in Kokomo, was one of the first people to develop stainless steel, and Haynes is still a really big player in the international market for different alloys. So I thought I'd go into not so much steel making, just a little bit of steel making and alloys, but also quite a bit on redox. We haven't done electrochemistry in a redox in several years, so that's going to be the main topic of it. And then sitting at Purdue, we had 2 Nobel laureates in organic chemistry, so I decided we would go into just organic chemistry per se, not what did Negishi or Brown cover, which we did a few years ago in boron chemistry. But so we're just going to go into the basic organic chemistry. So I want to give you some things that you need to know about those. Okay. The first thing is they're going to have to know how to determine oxidation numbers. So they have to know the rules. They have to memorize the rules for oxidation numbers. Those are in any organic or any high school chemistry text or any college chemistry text. They have to be able to identify what types of reactions are redox reactions. It's like love and marriage. You can't have one without the other. So if you've got an oxidation, you've got to have a reduction. And they need to know what oxidation means. I used to tell my students, Leo the lion says GER. So loss of electrons is oxidation, gain of electrons is reduction.
Excuse me, is this on the CD?
I think, slide? Yes, it should be on the CD. Okay. Yeah, it should be on the CD. They have to know what is reduced and what is oxidized in a reaction. And they have to identify the oxidizing agent and the reducing agent. Agents are only reactants, so some of the distractors will be products. So your students have to know that something that causes an oxidation is itself reduced, and something that causes a reduction is itself oxidized. So they're inverse relationships there. They have to be able to calculate cell potentials. They will be given, and I've asked those to be 40-second questions. They have to be able to look at a table of half reactions with the cell potentials there, and then do the calculation for those. They have to be able to interpret the cell potentials and put 2 together and say, which way does this go? Which one's oxidized, which one's reduced? And they do that by knowing whether the cell potential for the overall cell is positive or negative. And then the difference between a voltaic cell and an electrolytic cell. A voltaic cell is essentially a battery. You can get energy out of it. An electrolytic cell is one where you have to put electrons into it from electricity through the wall, and you will produce then you'll plate something out. So, did you have a question? Back there? You just stretch it. Okay, you get your shoulder back in place. Okay.
Can you repeat what you just? What are what type of cells?
The voltaic cell is a battery, and an electrolytic.
Science teacher, sorry.
That's okay. An electrolytic cell is one where you are plating things out. Like if you have an old copper boiler and you want to replate it, or you have jewelry and you want to put a new coating on it. Okay. Salt bridges. Why are salt bridges used? What are the characteristics of salt bridges? And the functions of the salt bridges. The conventional representations for a cell. So if you are going to have the equations for a cell. You can represent them going from the anode to the anode solution, to the salt bridge, to the cathode solution, to the cathode. And you can have those in order. Your students need to be able to look at those classic representations and then generate and figure out what's the oxidation reaction, what's the reduction reaction for it. Here's the big thing. They will not have to balance any redox reactions, okay? So if you're taking this back for the coach and you don't know how to, you just tell them they don't have to balance them, because that can be a real headache, okay? Even for your AP kids, balancing. So, and it takes a long time to balance one, or some of those, so you don't have to balance it. That doesn't mean there won't be balanced equations on there that they have to identify things for, but they will not have to do the balancing. As far as steel making goes, they need to know the basic terms for steel and alloys. They need to know what impurities are the things that are added to different steels to make them harder, to give them different properties. They have to be able to do a percentage composition problem. So if I give them 3 different ores with chemical formulas of the main components in them, they have to be able to figure out what's the percentage of iron, what's the percentage of oxygen in those. Two of the processes that alloys go through are hardening and tempering, and they need to know what the purpose of each of those is and what the process is. Why do you harden steel? Here's another one. There is nothing on blast furnaces. Okay? The newer chemistry books don't even have a section on them. If you dig into some old chemistry books, they'll have sections on blast furnaces, but the technology has changed and it won't match up with what they find on the web. And it's just too, there's enough here to do on electrochemistry that we really don't have to get into blast furnaces per se. As far as organic chemistry goes, we're going to just touch the surface of polymer chemistry, simple addition polymers. The reason I wanted to go into the polymers a little bit is because of the race cars having so much plastic in them now. And Howard's going to do some stuff on the Indy 500, so I'm trying to make a connection there. They do need to know the general formulas for alkanes, alkenes, and alkynes. And those they can find in any chemistry book. Naming simple compounds just through 8 carbons, so they need to know the prefixes through oct. They need to be able to determine which ones of these compounds would have cis and trans isomers. Not necessarily naming them, but they have to be able to look at them and say, does this have a possibility for cis and trans isomers? There will not be anything on, if some of you are familiar with the new nomenclature, with the E and the Z nomenclature, we're not going to be using E and Z at all. We're not going to be using R and S for chiral carbons or anything like that. So it's just the basic introduction to organic chemistry. They need to know the primary functional groups. They need to know alcohols. They need to know the difference between a primary and a secondary alcohol. They need to know ketones, aldehydes, ethers, and carboxylic acids. And then here's a tie-in to the electrochemistry and the redox. They need to know how oxidation or reduction can change one organic functional group into another. So why does cheap wine turn into acetic acid if you try to save it? And then as far as the plastics go, they need to know the difference between thermoset and thermoplastic polymers. And again, relating that to the race car bodies. For your references, any college prep chemistry book is going to have this at the back end. The later chapters, certainly the AP chemistry textbooks or college chemistry textbooks are going to have that. For steel making, there are many generic sites on the internet available. I would suggest that you assign different students to look and do searches and then share with each other rather than you doing any of the work there. And then an internet search can define the differences between the thermoset and the thermoplastic polymers for you. This is a typical question. They will be given those tables. In fact, I think all of my questions are taken from this particular table. The negative and positive signs are important on the cell voltages. Those are all written as reduction potentials. If you want it as an oxidation potential, you have to change the sign and reverse the reaction. But this says a voltaic cell contains a strip of zinc metal and a solution of zinc ions in one half cell. The other half cell contains a strip of tin metal and a solution of tin ions. When the cell operates, the cell potential is. So basically the options are you take the difference or you add them up. And it depends which direction you're going, okay? So if the one is oxidized and the other is reduced, okay? So the zinc in this case is oxidized, and so it would be a positive 0.76. And the tin is going to be reduced, and that's going to be a negative 0.14. You add those together and you get the positive 0.62 volts. Here's an oxidation number. It's a little bit tricky because it says you have to do two calculations. It says in which species does chromium have the same oxidation as it does in the Cr2O4 2-. So they have to look and see what are the calculations to calculate the oxidation number of each of those. And again, the oxidation numbers are, the rules are very straightforward. And so it's in the Cr2O2. What statement is true for a voltaic cell? And I'll just tell you all that in any kind of cell, oxidation always occurs at the anode. Always, always, always. And reduction occurs at the cathode, so it doesn't make any difference what kind of cell it is. Here's a question on different terms that you will see associated with alloys, such as steel. Any degree of hardness can be obtained by which process? All of these processes are processes that happen with alloys in producing steel, but tempering is the one that you can adjust the amount of hardness that you need. Here's one that when I said you had to know the difference between the alkenes, and alkynes. If you know the general formula for alkanes, it says no multiple bonds, so that's going to be CnH2n plus 2. So in this case, the only one that would fit that, if you have C2, which are 2 times that would be 4, plus 2 more would be 6. So C is the only one that has the option, because the first one is CnHn, the second one would be CnH2n, the third one is CnH2n plus 2, and the fourth one is CnH2n. So the only one that fits the alkane with the no double bonds or multiple bonds would be C. Of course, they could try to draw them out too, but in 20 seconds, it's a little hard to do. And then one about plastics. What's true about the type of plastics used in car bodies to decrease the weight. So they have to know what the plastics are and some of the characteristics about them. And an alcohol question, which contains the greatest number of carbon atoms. So they have to know the prefixes. Pro is 3. They have to know what glycerol is. Glycerol is a 3 carbon, 3 alcohols on it. Butanol is, but is 4, so that's going to have 4 carbons. And ethylene glycol is going to be 2 carbons for the F. And so the one that has the greatest number is going to be C, butanol. And again, if you have any questions when you look at the other, I think there's 25 or 26